So today we will talk about replication module in GlusterFS. So this is the scope. So we will look at the placement of the accelerator in the GlusterFS graph and the location of it, whether it's client or server, etc. And then we will also look at the most important on-disk data representation that is present in replication, that is managed by replication. Then the third one is on-disk data manipulation, how we actually keep this data represented on each file and directory using etc. Etc is like an internal operation that we have only come up with. So that is something that we will see. Then we will look at the common FOBs that are used in replication. These don't follow any transactions like that are followed in either read or write transactions. But yeah, so that is one more thing that we will look at today. All right. So first thing is the graph placement. On the data path where we do IO, replication translator, which is actually called AFR, automatic file replication, that is actually placed on the client mount. So the mount process will load this graph, and it will be present on the client machines if you have like separate clients and servers. It will also be present in this self-heal daemon graph, which will take care of automatically healing the files. So these are like internal clients. The self-heal daemon clients are internal. The mounts are external clients. So that is just the terminology. And as I don't know whether you guys remember this, but when we talked about client and server translators, we talked about this nature of client translators being the leaf translators in the client graph, which actually talk to the bricks over network. So the replica is placed just above these client translators. So if you have replica 3, you will have a replica node with 3 separate client translators that are in replication. So I'll now show them in the wall. I don't know that. Okay, I think it's just demo. All right. Increase the font size. Is this visible, guys?
Yes.
Cool. Let me actually give more distribute. All right. So we will check the wall files here. This is the mount wall file and this is the self-heal daemon wall file. Let's look at this one first. So we have these client translators. Okay. Since I have created replica 3, there will be a replica translator that is parent of. Okay, sorry. Oh, I think it is listing all the client translators once then. Okay, yeah. So all the client translators are listed that are like, I have created what? Okay, 3 into 3. So it is like 9. So yeah, till client 8. Each of them corresponding to one brick based on the, because all of them are local, remote hosts will be same. And this is like the path in that machine. Now after that, like each replica translator will have 3 bricks that are 3 client translators rather that are children to each replica translator. So you have something like this, like there will be 3 such reply 0, 1, 2. Okay, so and DST will be parent of all these replicas, but yeah, that we'll look at some other time once we talk about when we talk about distributed translator. But so this is how it is represented in the mount wall file. If we actually create another volume, that probably is okay. So just like we saw this, I think now we will have, there will be another volume, and here we will have this R3V1. So it is similar. I just created it to show how it will be when we have multiple volumes. So per mount there will only be one graph, but self-filled daemon graph is a little bit different. Maybe we'll look at it this one. I don't know if it will print everything or not. Okay, so as you can see, it will have graphs of both R3, the volume R3. Okay, so it has R3's graph completely. Only till replicas, so there won't be any DHT. The rest of the graph is not there. Okay, and then it will also have R3's graph. So this one will have multiple graphs. Okay, as you can see. And the replica options are also a bit different. So it says I am self-filled daemon S. So this kind of differentiates normal mount versus your mount, the self-filled daemon. You can probably see them side by side. Picture. Yeah, so if you look at this, for example, R3 replicate 0, you will have some of these options, but here you have more options like, this option, this option, this option, and whether self-filled daemon is enabled or not. All these things are okay. So this this I am self-filled daemon, yes, it's not here. It's not on the mount. It is only on the self-filled daemon. So this actually gives it more capability. Based on this flag, it actually goes to the indices that are present in respective brick and triggers heat. So that is one background operation. This will keep doing every 10 minutes maybe. I think there is an option to set that time interval, after which it will keep checking whether self-fill is needed or not. Yeah, so these are the two main graphs that I wanted to show. Any questions, guys, so far? The next one is going to be about data representation.
Yeah, in the PS output, it will not show, or like it will show the first volume only, right?
Yeah. So the okay, so there is a bit of a. So this is bound to change. I'll just tell you what is happening. So so when we look at this wall file, where are you? Okay, yeah. So this one, it only shows the first one. But whenever you create a new volume and stop a new another volume, it will dynamically change. Okay, but we are going to move away from this and go back to the earlier situation that we had. where this will be just SHD, wall file will just be SHD. I think Rafi sent an PR for this. It is under review or it is in work in progress at the moment, but we will remove this dynamic loading and unloading of the graph because it was leading to some problem. But yeah, what you said is correct.
That means it will be like one SSD per volume, or it will be single SSD per node.
It will be single SSD per node.
Okay.
It will do multiplexing.
Okay. If it is not dynamic loading, then SSD will be restarted.
Restarted, yes.
Okay.
Okay, but these are all like, it's just like, this is what we have seen in production a lot. So we are going back to that. But if your use case needs multiple self-fill demands or self-fill demand per volume, that also can be done. But it will need changes in Gluster Dev. So these are all like flexible. It's not a big problem.
Okay.
Okay, so yeah. Any other questions? Okay, all right. In that case, let's move on to the on-state representation. Okay, so as I was mentioning, whenever I was talking about data representation, even AFR actually stores the data that it needs, metadata it needs, in an extended attribute on each of these files and directories. I'll in a moment show how it would be on the file. But for now, theoretically, if you think about it, there are like 8 bytes. So in total, it will be 4 bytes. In total, it will be 12 byte value for the extended attribute. First 4 bytes represent the changes that are done on some other brick when something was down. So I'll explain this with an example in the demo. But just remember that if this is not, generally if it is 0, everything is fine. Anytime it is not 0, it is basically saying some brick has pending operations. So if this is non-zero, that means it knows that some other brick has pending data operations. If it says this is non-zero, then while some brick was down or some failures were happening, somebody did like a chmod or a chown, or maybe changing the time. Some metadata of the file was changed. And this is for directories. Where while one brick was down, some new files were created or deleted or renamed, or hard links or soft links, all of these things. Those pending operations will come in, will be maintained in this. So together, like looking at just this external attribute on the directory or the file, you will always be able to tell whether this particular file needs a heal or not. So this is the first day on this data representation. And if you remember, we also had this index translator presentation a few sessions back. Even that maintains the GFID that needs to be healed based on this being non-zero. Okay, if any of this is non-zero, then it will create that index in that directory for replication. Okay. And these are generally the names of these extended attributes. The first one, like till this client X, right? This means a definite pending operation. This trusted.afr dirty, you actually set it when you are doing an operation. So while the operation is in progress, this will be set. So if you are doing a write operation, this will be non-zero. As soon as the operation completes, it will become 0 again. Similarly with other, so there are some optimizations that we will discuss in the next few sessions, but the basic idea is that. So the unoptimized operations, they generally, whenever they are modifying the file in any way, they basically modify these things and then do their operation and then reset those numbers. Okay. So now we will see how this manipulation is done. So there is an operation called hexadrop in POSIX translator, actually in Gluster Dev. So you can send a FOP file operation on that file or a directory. So you will basically send 12-byte array, and POSIX translator will do an add for each of these things. Like initially, let's say if it is all okay. So here is the example. So let's say this is the initial thing. Okay. Initially, the file has the external attribute 12, 4, and 0. Oh, by the way, as an aside, if it is a file, you will have data and metadata operations. If it is a directory, you will have entry and metadata operations. This was like a tiny bit inefficient if you think about it, because the entry operations for a directory can be considered as data, but this is how it was implemented at the beginning. And this, like, for backward compatibility, we just did not remove it. But generally for files and non-directories, you will have these. For regular files, you will have data also, but for like some special files like device files, etc., only this will be set and reset. For directories, these two will be set and reset. Okay, so back to our example. So let's say initially we have this extended attribute present on the file, where it says there are 12 pending data operations on some other brick, 4 metadata operations that are present on that are pending on some other brick, and 0 entry operations. You, like an AFR can send an hexadrop operation with a +1, 0, and 0. Okay, it's like an array. You are sending like array of integers. You are sending it. Then it will do this addition and set it on the disk. So it will become 13, 4. So like 0, I am representing by no data in that cell. So it will become like this. So you can also send decrements. So let's say if it was like 12, 4, and 0. And if you want to decrement something, you can send like 0, -1, 0, and it will become 12, 3, and 0. So this is what hexadrop does. We will look at the code also for this. I think, yeah, let's go to the demo. The graph representation, I think we are done. Let's look at the hexadrop representation. Right. Okay. So, okay, maybe there are too many. Okay, but I think it's probably fine. No, I think it will be confusing. Okay, 1 second. Let's just do it with single replica. That's a bit simpler. Okay. So if we do something like, so it would have created one file with 1 MB, right? So you can see that it is there in all of these. So we can do get a factor also on 1. So you will see this dirty thing, right? It's all zeros, and you can count them, like 1, 2, 3, 4, 5, 6, 7, 8. So this will be data, and 1, 2, 3, 4, 5, 6, 7, 8. This will be metadata, and this is like the entry part. But since this is a file, this will always be 0. Okay. Now let's do something. Let's kill one brick. I am going to kill the first brick. So we are going to do the same DD operation. Okay, we are done. So if we look at 0, so there is nothing here, like it's the same external attributes that we had before. But if we do the same on this, now you will see that there is this R3. R3 is the volume name, and client 0. Client 0 is the first brick. Like generally, unless you do like a lot of add bricks and remove bricks, right? The numbers will be in serial order. Like this will be 0, 1, and 2. So because we killed the first brick, it is like the 0th one is down. So it is saying some 2 operations are pending on the other one. So generally this number may not be that important based on the optimizations. So even if you have, let's say, even if you do 1000 operations, because of some optimizations, it can just show 1 here because it is equivalent. But that we will look at in the inode operation, write operation session that will be discussed next. But so this is what represents that there is a file that is that needs self-heal. So now if you look at this R32, sorry, Gluster FS. Indexes, etc. So you will see that this 2F, so this is the GFID, right? 2F6C something something. Yeah, so that file is now here. Because it is non-zero, the index also gets created. So this is like a watch. Index translator actually keeps a watch on this external attribute. Okay, so now let's do a ch mod 777 on 1. And now you will see that even like, the metadata thing also changed, right? And let's create a new file. Okay, wait, before that I'll show. So you are not seeing any pending external attributes here, right? So if you create a new file, HB, let's say, and you will see that this got a new pending operation. So that is how it is. So basically it is saying like whenever you look at an external attribute, it is basically telling you multiple things. One, what are the types of things that are done while that brick was down and which brick was down. So client 0 represents this brick, this first brick that we have taken. Similarly, if we take this one down, it will be client -1 on this and this. So always these external attributes will show up on the ones that are alive. Okay. So for those who want to read up more about these things, there is this concept called version vectors. So this is an implementation of that. Okay. All right. So this is what I wanted to demo. Are there any doubts in this? Okay, I'm assuming everybody has gotten this. All right, so let's ask a quick question. So what is the meaning of this? Oh, these are the exact external attributes. Huh? Okay, all right, but still, let's see what is the first one mean? Anybody? Hello?
You were able to hear you.
No. This is like a question just to see if you guys have understood or not. What is the meaning of this one? Because this is like central thing. If you guys don't understand this, the rest of the sessions are meaningless.
Data metadata heal pending on client 0.
Yes. For the file A, data and metadata heels are pending for client 0, whatever is the brick that represents this one. What about this one? Somebody else. That was Sheetal, right? Yeah, somebody else. What is the meaning of this? Okay, let's go over it then. So this represents which part of which type of change? The first 4 bytes, or rather the 8 hex digits. Okay, let's go back to this one. First 4 bytes are.
Yeah, Chetan responded in the chat.
Oh, okay. Sorry, I did not see. Entry heel pending on. Okay, perfect. So yeah, that's what it means. So basically, some directory operations are pending on the first brick in this replica set. So as soon as this, oh yeah, we can actually bring this up. So if we do this, I think heel would have been completed, and you are seeing that it has become all zeros again, and it would have created these files on 0. Okay, so the B is created now. Okay, so this is how it. I think you can also see it for A. Or was it 1? Yeah. So even these things have become zeros, right? So yeah. So that's what these extended attributes represent, and this is like the most important thing. So now that you know this information, let's say all these bricks are up, okay, and you have 3 copies, okay, R30, R31, and R32. You have these pending markers from on client 0, and let's say for some reason self heal is not happening, okay, and if you send a read operation or a stat operation, which response will you choose? Let's say you get like the responses from both the first brick, second brick, and third brick, and as per these extended attributes, first brick is not good, right? So when you want to show the data to the user, which bricks will you choose to read from? Any ideas? I'm asking these questions because these things will become easy if we know just this much. Can we serve the data from the first brick if the heal hasn't completed? The one that is represented by client 0. Okay. The brick which is blaming the others. Yes, perfect. So basically, either the first brick or the second brick. So there are 3 bricks, and I've always shown only the R31, but R32 also would have something similar. This client 0 will be non-zero. So the response would be actually gathered either from R31 or R32, but not from R30, because both of them are saying like it has some pending operation. So we don't want to serve stale data to the user. So now you probably understand how these extended attributes are useful to serve data, correct data to the user. Okay, so now that this intuition is there, let's look at some of these operations that are simple. Actually, lookup operation is not at all simple, but it doesn't have, yeah, let's look at it. Like lookup, as you probably guys know, that is a name to GFID mapping, and it all, as part of lookup, it will also serve the stat structure to the client. So when you do a lookup on a file, that lookup will be sent to all the clients that are available. That means all the bricks that are available. Okay. Now in the responses, you will check these external attributes and see which of them are good and which of them are bad. Okay. And it will also trigger self-heals if it needs to, based on the options that you have. But it will always serve the metadata and any other information from the external attributes, like the bricks that are good. So that's what lookup operation will do. Similarly, for open operation, open, as you guys may know, given a path, it has to give an FD. So here, like open, you can send it to anybody. It's just opening. It does not mean there is anything good or bad. Like you can send open everywhere, and you can just keep that FD with you and send that as a response. There is no problem there, because you are not really serving any data that is there on the files or directories. You are just giving a handle to the client to do rest of the operations. So there is no problem here with good copy versus bad copy in this open. Same thing with flush also. Flush is like close. When you do a close, a flush operation will come to GlusterFS. It also does these checking. So I was mentioning, right, when you are doing these DD or whatever, it does these optimization. So Flush actually will make sure that all these optimizations are completed. Meaning, just before closing the file, we want to make sure all the external attributes correct, etc. So that part is taken care by Flush. So when a Flush operation comes, you first basically send complete all the background operations on that FDI and inode, and then you will just send this flush operation to everybody. Okay, so this is still like theory only. Now we will take a look at the code, probably starting with lookup. Okay. So it is in Accelerators cluster AFR SRC. This is the directory where all the code for replication translator is present. AFR is automatic file replication. Okay, so let's look at. I'll give a brief overview, because in-depth thing is going to go over our heads if I try to explain it to the dot. Okay, so lookups, this is something that I have explained in POSIX translator or dev session, or one of the ones after that, where this LOC can have GFID based lookups and name based lookups in a directory. So if it is nameless, the code path is different. It's called discover. It's just like it will be based on GFID. It will do something similar to that of what a lookup does, but the code path is a bit simpler there. Okay, so that is one. So this is like your external attribute. So basically, to figure out which bricks are good or bad, you need to you basically need to set up these external attributes that you want to fetch from that file. So we will check what that is like. So here it is doing this preparation. So, so these are some more. Okay. So this is the first one probably. So these are like pending keys. So okay, I think I may have to show what these pending keys are. So there are, so these are like depending extended attributes. So R3 hyphen client 0, R3 hyphen client 1, R3 hyphen client 2 are the pending extended attributes. So these pending keys are constructed at the time of initialization of this translator actually. So let me, yeah, pending etc. Okay. So it will basically get this list of external attributes. Then for each of these pending keys, sorry, each of these external attributes that are delimited by commas, it will uh, do this like percentage dot percentage, which is this exciter prefix is trusted.afr. Okay, trusted.afr, and then dot this accelerator name. Okay. Which is like your what is this? Like your R3 here. Actually, one second. Okay, so this is if the exciters list is not there. So this is for backward compatible. So I was thinking there is a bug here. Why is it like this? Because you are supposed to populate it with this these exciter list, the one that is present here, right? So I think that is handled here. Yeah. So yeah, you do this tokenization. So you split this string with commas, and then for each of them you just populate that, like trusted.afr dot, and then whatever is this string R3 client 0 or R3 client 1, something like that. So you basically populate it like that. So when you are doing this lookup, you are basically going to ask POSIX translator to get the values of those. Okay, you're also trying to get whether this trusted.afr dirty is also set. Okay, so yeah, it is this trusted.afr.dirty. Then, so there are some other external attributes also that it will try to get. Then there is this inode LK count, entry LK count, and parent entry LK count. So these are to see whether any ongoing operations are in progress on this file. Okay. Then once these external attributes are prepared, you are going to basically send this request to all the bricks that are up, one after the other in parallel. So this is like async way of you are basically stack winding it to lower translator with this client translator here, and that will send the request over the wire. Now, once the responses come, you are basically what you are going to do here is to see whether like if there are any heals that are needed, you will do that. Okay, but let's assume in the normal case you won't need any heals. So all this code is to check whether it needs any heal and heals and all that. It will also check whether it needs any metadata heal also, I think. Yeah, so there is something about metadata heal also. So if that is also needed, then yes. Otherwise, it will just do that lookup is done. Now so it was trying to see whether these any LKs are in progress, right? That is to figure out if any transactions are in progress. Based on that, it will take some more decisions here. But yeah, so this is the main part. So you are basically going to get the responses, and then you will yeah, so this is the one, like replace, interpret, and read subvolume decide. So these are the ones that are going to tell you from which brick it is going to decide to send the response. Okay, so essentially, like if you see this, like read subvolume is the one that it uses to send the response from. It would have had like if there are 3 replicas, there will be 3 such replies in this one. Okay, but it is going to choose that from read subvolume, which is going to be gathered in this read subvolume decide, which is going to do all these extend add. So it will do that. What are these, like it will figure out which is data readable, metadata readable, etc., etc. It will do all that, and based on that, it will say, okay, give all this information from one particular brick. So based on that, response will be chosen. Okay. Did you guys understand this like at a high level? Because there are like too many cases in lookup, because it is the main operation. Like if you look at any of these translators, lookup is like the difficult FOP in most of them, most of the cluster translators, because lot of things would be in progress and you need to still figure out which one you want to show to the user. Like let's say just at the time of doing the lookup, a rename could be in progress. Just at the time of doing the lookup, an mkdir could be in progress. So all of these corner cases need to be handled. So generally lookup is a bit the code is a little bit big, so it's probably better if you guys go through it in detail based on what you want to understand. But the main thread is that you are trying to figure out from the list of replicas that are available which one you want to show to the client. So yeah, any doubts here? Okay, I am assuming no. All right, so this is the difficult of the ones that I tried to show today. Like open and flush are like really simple. Okay, so it's just like, so yeah, in open you're basically trying to give an FD for an LOC. So there is one extra thing I think. So it makes sure that the truncation happens inside a transaction. So basically, anytime you have any data, metadata, or entry operation, it all needs to be serialized and done inside a lock, so that you won't have inconsistencies. So that part is taken care by open if the flags have some O-trunk flag or some such thing. But yeah. Otherwise, it is just like a simple, you are just going to do a winding of open on each of the bricks that are available. And then you have this, like you get the responses wherever it succeeds, it will say FD is open and it will store it in the FD context. You guys remember the session about FD context and inode context and all that? Like per resource, you can store some extra information per translator. So that is what is happening here. So it is storing that this file is opened on this brick and this file is not opened on some brick. Okay, so this is going to be important later. That probably I'll show. But I think if the open is not successful on quorum number of bricks, I think it is treated as failure. So this is what is happening here. Okay. Like I was mentioning, if there is an O trunk flag, it will do a truncate as a separate transaction. Okay. So yeah. So this is one more thing. Now maybe I can talk a little bit about this FD not open. So the thing is, let's say when you send an open, and at that time, let's say one brick was not good, or it was down, or you are doing some maintenance on that brick, so you took that brick down. What should happen to that FD once that brick comes back up? At some point, you have to do reopen on that file once you deem that brick operational, right? So every time an operation is done on this FD, a check will be done to see whether you can open on this. So there is this there is this thing called open FD fixing. Okay, so every time you have an FD that needs to be fixed, which means it is not opened on some brick, then you will attempt an open. Okay, it will be like rate limited, because you for every operation you should not be doing open. But yeah, so that also will be done. So this is like a kind of a self heal on the mount. So once this FD gets opened, if another brick goes down, it's still fine because this FD is now open on some other brick, so you can still do operations, assuming like the file is still in a consistent state. So these things I think we will touch upon even when we are going to talk about heal. But yeah, so this is one thing that that happens for open. Okay. Final thing that I wanted to discuss about is flush. So flush is, as I was mentioning, it is like a reverse of your open. It generally gets called when you are closing the file. There are some other places also where flush gets called, but the significant, like the important moment when it gets called is just before closing the file. I'm like a close call will lead to a flush call in fuse. Okay, so here this is what I was mentioning about where if there are some delayed operations or some optimizations that happen, you create a stub out of this flush operation and you complete your background operations. These things will be discussed in the next session. That's why I'm going over them just like that. So basically there is a concept called eager locking and delayed post-op to reduce the number of metadata operate like these exatrops and logs that you have to take. You optimize that code path basically. Once that part is done, it will do this resuming of the this stuff. Okay, which is like the flush fork. So once the background operations are completed, the flush operation will again look similar to you guys. So for each of the bricks that is available, it will send a flush operation. And based on the response that you get, you will just send a response to your parent translator. So that's what happens. Okay. So I think even StatFS is something similar. StatFS, is it, or is it only to one? Yeah, so this is also similar. StatFS is like your when you do DF on your machine, StatFS will come. So this also, like, you know, you will basically send StatFS to all the children. You gather the responses and you send. You will do some manipulation of the responses based on which one has higher, lower size. You will show only that amount as the available space, and those kinds of things you will have to do, and then send the response. So, but most of these operations they will be similar. So I'll try to, now that we have gone through this, I'll try to show some types. Okay. So if you look at all the FOPs that AFR handles, you can see like 3-4 types. The ones that we have seen today are like those forks get sent to all the bricks, like lookup, flush, status, even fsync there, and fsync also gets sent. But the lock operations I think are separate, that we will discuss in the next session. Even lease also is kind of a similar to these synchronization. They are also a way to synchronize between clients. Then in the third session, we will talk about these read operations, which generally get sent to only the good bricks. Okay. And the write transaction is a modification transaction, which modify the data part of the file. Okay. So, and even the metadata, like inode write here is not just like a data operation. It also has this metadata operation, like anything that modifies. So all of these are like inode read operations, and all of these are like inode write operations. Then you have directory operations, I think. Yeah. So directory write operations are like, creating and deleting files, rename. And then you have like opens and directory. So this is one more type. Okay, so today we have covered like opens, like opendir and open are almost same, so you don't have to worry too much about them. So in the next session we will talk about inode reads. Like all of these things will have a similar pattern, just like the lookup, open, statfs, and all of these things are always sending operations to all the bricks, and based on the responses they are trying to do something. Inode read is going to do, and like it will also be like similar in a way. Like all of these things will do something similar. So it's called a read transaction. That we will discuss in the next session. Okay, so yeah, that's it for today.